seventh graders. So the last video we discussed the difference between independent events and dependent events. All right, and how if one event impacts the second event, they're dependent. If the two events have no impact on each other, they're independent. All right, now how do we find the probabilities of these events? Well, we multiply. All right, I think that's a question on your challenge board. You multiply their probabilities. That's the answer. Write it down. All right, so I was actually looking for marbles here. I can't find my kids' marbles. They've actually lost their marbles, both literally and figuratively. All right, so I don't have marbles, but I drew a picture. All right, so let's say I have a bag and it has 6 marbles, and let's say we have 4 white marbles, 2 blue marbles. All right, and I want to know what the probability of getting a white marble is, followed by the probability of getting a blue marble. All right, let's start with the independent case. So I draw one marble and then I put it back. I replace it. All right, so with replacement. All right, so if I draw, what's the probability that I draw a white marble, put it back? So I always have 6 possible marbles, and then on my second draw I draw blue. All right, so the independent version, the probability of me getting a white marble is 1, 2, 3, 4 out of 6 possible marbles. Now I need to multiply that by the probability of getting a blue. All right, now since I put that first marble back, my probability of getting a blue is 1, 2, 2 favorable outcomes over 6 possible outcomes, so 2 out of 6. All right, and now I can just multiply these probabilities together. All right, I could do 4 times 2 is 8, 6 times 6 is 36. So my probability is 8 out of 36. All right, on IXL, I don't remember if they want you to simplify. If you do have to simplify, you could either cross-reduce up here when you're multiplying, or once you get your final product, all right, just divide the numerator and denominator by a common factor, or the greatest common factor. In this case, our greatest common factor, I think, is 2. It is. Or 4. Why did I say 2? So 8 divided by 4, 36 divided by 4. That simplifies to 2/9. All right, so my probability of getting a white on my first one and a blue on my second one is 2/9. Those are independent events because I put the marble back. Now, for dependent events, what's the probability that I draw a white, keep it out, and then on my second one, I draw a blue? All right, now this is dependent because I'm not putting that first marble back. So the probability of getting a white on my first draw is still 4 out of 6 because I have 4 favorable marbles, 6 total marbles. Now I need to multiply that by the probability of getting a blue. Now this probability has been affected because I'm not putting back that first white marble. All right, so if you want to visualize, you can cancel out one of those white marbles. So now my probability of getting a blue is 2 favorable marbles divided by 5 possible outcomes, because now I only have 4 marbles, or 5 marbles, excuse me. All right, so I have 4 6 times 2/5. I multiply these together, multiply straight across with fractions, so we get 8 out of 30. All right, so my probability of drawing a white, then a blue, without replacement is 8 out of 30. Again, I can simplify this. Our GCF is 2, so that is 4/15, which is my probability. All right, so my probability for the dependent version is 4/15. The probability of the independent version is 2/9. Now, I can't remember if IXL wants you to give these as decimals or percents, but let's do it anyway. So if I want to write 2/9 as a decimal, I just divide. So I would do 2 divided by 9. All right, 2 divided by 9. All right, that's just 0.2 repeating. I knew that, and you guys know that, because anytime you have a fraction over 9, all right, it's the numerator repeating, okay? So that's just 0.22 repeating, all right? And then my probability of 4/15, if I want to write that as a decimal, I would do 4 divided by 15. All right, and that's 0.26 repeating. 0.26 repeating. All right, so we've got fraction, decimal. We could also write these as percents, guys. All right, don't forget your dupe strategy. All right, so decimal, 2%, you move your decimal place over 2. All right, so this would be 22.2%. This would be 26.6%. And I added on, and I put that repeating bar because, you know, these are both repeating decimals where that 6 goes forever, these 2's go forever. All right, one other example we need to do because it does get a little more confusing than this. So let's stick on the dependent side, stick with our marbles. What's the probability of getting a white marble on the first draw and then a white marble on the second draw without replacing? Okay, so my probability of getting a white on my first draw is 1, 2, 3, 4 out of 6. All right, now I need to multiply that by the probability of getting a white on the second draw. Now, on the second draw, remember, I'm assuming that I drew a white on my first one, and I'm not replacing it. So I could actually cover up one white marble. So now my probability of a white on the second draw, I only have 3 favorable outcomes, all over 5 total outcomes. All right, so that second probability was really impacted. Now I can multiply straight across, and that gives me 12/30ths. All right. Again, I probably should simplify, so I'll divide by 3, divide by 3. Actually, I could have divided by 4, but I didn't. All right, so 12 divided by 3 is 4. 30 divided by 3 is 10. I still didn't simplify all the way. No big deal. Both even numbers, so they're divisible by 2, divided by 2. And that gives me 2/5. All right, so my probability of getting a white and then another white without replacement is 2/5. All right, that's one of those fractions you guys should memorize. That's just 0.4 or 40%. All right, if we're talking percentages. All right, guys, so hopefully this helps with dependent events. The skill on IXL I have you guys practice mixes the two. All right, so remember, if you see an independent event, the two probabilities aren't really impacted by each other. If you see a dependent event, that second probability is going to be impacted. All right, so make sure you adjust it accordingly. Multiply the probabilities. All right, make sure you guys email me with any questions.